Hi, I'm Rory Nealon, Application Engineer in the Radio Transceiver Multi-Market Platform Group here in Analog Devices. In this video, I'll introduce the Radioverse ADRV9002 evaluation system. The ADRV9002 is a dual-channel narrowband and wideband transceiver platform. It's our first narrowband and wideband single-chip FDD and TDD integrated transceiver. It has two independent receive and transmit channels and two independent on-chip RF that can be routed to any of the receivers or transmitters. It has an RF tuning range from 30 MHz to 6 GHz and has a scalable bandwidth of 12 kHz to 40 MHz per channel. It has a user-defined serial LVDS or CMOS data interface and comes with signal correction algorithms or tracking calibration algorithms. ADRV9002 offers a number of advanced system features, such as fast profile switching for dynamic data rates and sample rates, flexible power versus performance control within the analog and digital circuits, a monitor mode for power and sleep mode optimization, multi-chip synchronization, fast frequency hopping, digital pre-distortion for narrowband and wideband waveforms, and independent auxiliary and control functions. Now let's review the components of the ADRV9002 evaluation system. The Zinc ZC706 is the system motherboard. The Ethernet cable inserts into the Zinc board, and there's a slot on the side for the SD card to be placed. The SD card contains the API software and drivers for operating the ADRV9002. The Zinc motherboard connects to the ADRV9002 evaluation board with an FMC connector. The top side of the evaluation board exposes two TX outputs, four RX inputs, both A and B pairs, two external LO inputs, multi-chip synchronization and dev clock inputs, and GPIO and control headers. Let's connect a clock source to the clock input and continue. The board also contains an onboard signal source of 38.4 MHz VCT CXO. Turn on the Zinc motherboard and we'll see the LED sequence. When the motherboard powers up, the LED turns off and the system is ready for connection via the evaluation software. On the PC connected to the evaluation system, we can start the transceiver evaluation software for the ADRV9002. We can now click Connect. Once the connection is made, we can now configure the evaluation board. First, let's select the desired use case. The use case defines the data rates and bandwidths for the transceiver. If desired, we can adjust the device configuration options in the Initialization tab. Before programming, it's important to ensure that the switch on the evaluation board that selects clock source is set properly. And if an external clock source is applied, the correct value is set in the Initialization tab. We're ready to program the device now by clicking Program. In case an error occurs during initialization, check the File menu, Log File for more information. Once programmed successfully, we can interact with the device as necessary. Now we can move to the Transmit Data tab. This tab can be used to generate CW tones and load data vectors. Here I'll set up a two-tone signal. I select Data Source, two tones, and then configure the tone frequency and amplitude. Then I click Play. The spectrum window shows time and frequency domain data for the waveform. Checking the spectrum analyzer, we can see the expected output. Now let's move to the Receive tab. Clicking Play allows us to view the input signals to the receiver. Users can adjust the gain level while receiving data. The Time Division Duplex Mode Configuration tab is provided to configure the TX and RX timing parameters for TDD evaluation. The ADRV9002 provides digital pre-distortion functionality. The operation of the DPD block can be done through the Digital Pre-Distortion tab in the GUI. Autonomous Monitor Mode operation, together with Power Saving Mode, is supported by the ADRV9002 transceiver. Access to those features can be obtained through View, Monitor Mode, as well as the Power Savings and Monitor Mode tab. Access to RX gain control of the transceiver is provided through the Gain Control tab. The current state of the ADRV9002 can be monitored using the View menu, Radio State screen. Software provides access to an onboard current and voltage sensors that provide live data on power being consumed by the ADRV9002 in selected mode of operation. The transceiver evaluation software can generate initialization code in Python, MATLAB, and C languages. Generated code will reflect the exact state of the ADRV9002. Further, an Iron Python scripting tab is available for additional customization. For more information, please visit analog.com/ADRV9002.